high pressure turbine isentropically. So these wordings are important, isentropically. Okay. Isentropically till it is dry saturated. Till it is dry saturated, full stop. The steam is reheated up to 400 degrees centigrade. The steam is reheated up to 400 degrees centigrade, passing through the reheater, full stop. Expansion after reheating is carried out. Expansion after reheating is carried out to condenser pressure. To 0.2 bars. To 0.2 bars. To 0.2 bars. Means condenser pressure is 0.2 bar. Full stop. Draw cycle arrangement and TS diagram. Determine thermal efficiency of the cycle. Second, work output in megawatt. If the steam flow rate is 10 kg per second. If the steam flow rate is 10 kg per second. Work of turbine in megawatt. Right? If mass flow rate of steam is how much? 10 kg per second. Right? Now first flow diagram. Now what is this process? This is the steam power plant cycle, Rankine cycle, where reheating happens. Right? So here, this is the boiler. Right? Where water converts into the steam. Right? This is your boiler where water converts into the steam and then it is sent to the first steam turbine T1 where it expands isentropically. Right? Then what happens after this? We are reheating this, right? So that low temperature, low pressure steam will come here and that will be reheated inside the boiler and again it will be sent to the second turbine. Turbine 2. Right? Then after this steam will send to where? Condenser. Right? Inside condenser, what we are doing? We are using the cooling water. Right? So here, cold water in. And this is what? Hot water out. So this steam will convert into the water and after this that will be sent to the So this is your pump. Okay, this is boiler, turbine 1, turbine 2. This is what? Condenser. Now where this hot water is going? Where this hot water is going? It is going to the cooling tower, where it becomes cold, and again coming back, right? That cycle is different. Okay, so this is what flow diagram, reheating. Okay, this is reheater. This is reheater. Now important thing is TS diagram. You have to draw the TS diagram correctly. Then 50% work will be done. Okay. Now see here, this is what input to the boiler is what? Cold water. Input to the boiler is what? Cold water. Output of boiler is what? Steam. Then input to the turbine is what? Steam. Right? So this is 2, this is 3. Output from steam turbine. Then that steam will be reheated. So this is what? 4. Input to the second turbine is what? 4. Right? Then output of second turbine is 5. Output of condenser is nothing but input to the pump, 6. So these 6 processes we have to show it on the TS diagram, right? So first draw this line. What is this line? First line. What is the name of this line? Saturated liquid line, right? Then this saturated vapor, right? Now this 1 is what? 6 is what? 6 to 1. Sorry. Numbering little we have to change. Okay. Actually this is 6. Okay, this numbering you can take anyway, but whatever we have taken because same notes I am going to draw. Okay. So this is going in. Input to the pump is what? 1. Liquid. Then liquid will be pumping process is nothing but isentropic compression. Pump के अंदर क्या होता है? Isentropic of compression. 1 to 2. 2 to 3 converting water into the steam, right? Then 3 to 4 is what? 3 to 4 isentropic expansion, right? So first 1 to 2. 1 to 2 is what? Pumping. Inside the pump, isentropic compression, right? So this is ES. Okay. Then 2 to 3 is what? Heating inside the boiler. Heat addition inside the boiler at constant pressure. Okay. So this is constant pressure line. 3. 2 to 3 is what? 1 to 2 is isentropic compression in the 3 is what? 2 to 3 is what? Heat addition inside the boiler at constant pressure, right? This line, 2 to 3 line is what? Constant pressure line, right? 2 to 3. 3 to 4, what happens inside the turbine? Isentropic expansion till the saturated vapor line. That is given in the problem, right? So, saturated vapor line. 3 to 4, vertical downward, right? Then 4 to 5 is what? 4 to 5. 4 to 5 is what? 4 to 5. Reheating. This is T superheated at point 3, and this is T superheated at point 5. We are reheating this up to the temperature 400 degrees centigrade. This is 500, so 400 will be here, and then isentropic expansion, right? 4 to 5 is what? Reheating. 4 to 5 reheating. 5 to 6 is what? Isentropic expansion in the second line up to the saturated line, right? So this is 5 to 6, 4 to 5 and 5 to 6, and 6 to 1 is what? 6 to 1 condensation in the condenser, right? So this is your TS diagram. Now what we need to calculate? Thermal efficiency. What is the formula for thermal efficiency? What is the formula for thermal efficiency? Thermal efficiency is a kind formula. Efficiency formula is what? Efficiency is a formula. Output of input. Now in thermal formula, what is the output? Turbine work for Rankine cycle. What is the output? Turbine work. Input is what? Heat added in the boiler, right? So thermal efficiency formula is what? Turbine work minus pump work divided by heat addition, right? So turbine work is what? Turbine work in first turbine, turbine work in the second turbine. So turbine work in first turbine is what? Turbine work in first turbine is what? H3 minus H4. Turbine work in second turbine is what? H5 minus H6. Pump work is what? H2 minus H1. And heat addition, all this is per kg, yeah? All this is per kg. We have to calculate enthalpies per kg and we have to use this. Heat addition formula, heat addition takes place from 2 to 3. So heat addition will be equal to enthalpy H3 minus H2, right? We have to calculate the enthalpies by using the HS chart and steam table, right? I have already told you to bring the steam table, okay? Yes. Up to here it is clear. Now next, from steam table, now open your steam table. Now what is the condenser pressure? 0.2. So enthalpy at point 1 is what? HF. HF is what? F stands for? HFP is what? HFP is what? HG is what? HFG is what? HFP is saturated liquid. HG means saturated vapor. HFG means liquid plus vapor, right? So enthalpy at point 1 is what? HF1, which is equal to H1. How we can calculate? By using the pressure. We know the pressure 0.2 bar. From the steam table, inside the steam table you have to look at here properties of saturated steam. Properties of saturated steam, pressure base, right? So here what is the pressure? 0.2 bar. Here 0.2 bar. Look at what is the value of HF. Saturated liquid specific enthalpy 1.45. H1 is what? 241 from steam table. HF1 is equal to H1, which is equal to 251.45. Unit is what? Kilojoule per kg. At pressure is equal to 0.2 bar. Right? Now we know that pump work. For pump work, how to calculate the pump work? Always remember, for pump work, to calculate the pump work, here pressure is how much? 70 bar. And here pressure is how much? 0.2 bar. What is the function of pump? To raise the pressure from 0.2 bar to 70 bar. That is the function of pump. So we can calculate the pump work directly by using the formula. Boiler pressure minus condenser pressure divided by 10. But this pressure should be in the bar. It should be in the bar, right? So you will get here 70 minus 0.2 divided by 10, right? So, but what is the formula of pump work in terms of enthalpy? H2 minus H1. Our target is to calculate H2. H2 minus H1, which is equal to, how much is this? 69 point 6.98. 6.98. Unit is what? Kilojoule per kg, right? So here H2 is equal to 6.98 plus 251.45. So H2 is how much? H2 is how much? Do this addition. 2.43 unit. Always talk with units. Okay. Now, how to calculate H3, H4, H5? How to calculate H3, H4, H5, H6? How to calculate this? By using the modular diagram. HS chart. At point 3, what I know pressure, I know temperature, so I can calculate enthalpy. Right? Yes. Now at point 4, how to calculate? This is isentropic process. So from this point on the HS diagram, draw the vertical downward lines till it touches saturated vapor line. So at that point you will get the enthalpy H4. How to calculate H5? First you have to calculate the intermediate pressure. You have to calculate intermediate pressure from HS diagram itself. Right? You will get the intermediate pressure by using that intermediate pressure and temperature. Temperature is how much? At 0.5, 400. So that pressure and temperature, by using that we can calculate the enthalpy. And how to calculate enthalpy at 0.6? Isentropic process, vertical downward line, till it touches the saturated vapor line. So at that point we will get the, right? So let us see how to calculate this. Now at point 3, pressure is equal to 70 bar, temperature is equal to 500 degrees centigrade. Is it correct? From HS chart or HS diagram. From HS diagram, okay, this diagram is not clear. We will take the another diagram. Okay, look at this. This is HM diagram. On x-axis, entropy is there. On y-axis, enthalpy is there, right? These lines, red lines, these are constant pressure lines. Okay. Then can you see these lines, black lines? They are curved and then they are horizontal. They are curved and then they are horizontal. They are constant temperature lines. Okay. Now at point 3, what is the pressure? 70 bar. So and this line is what? This dark black. This is what? X is equal to 1. X is equal to 1 is what? Saturated vapor line. Right? Here X is equal to 0.95. This line is what? Saturated vapor line. Okay. Now at point 3, pressure is 70 bar. So this is 100 bar, this is 50 bar. So in between this 70 bar will be there. Temperature is how much? 500 degrees centigrade. This is the 500 degrees centigrade line. You can see the 500 degrees centigrade line. Okay. See here. This is the 50 bar, 100 bar. So 70 bar pressure line we can draw here, somewhere here. Okay. Then 500 degrees centigrade temperature line, constant temperature line, where it intersects this point. So at that point, what we will get? H3. So from here, project the horizontal line. Project the horizontal line. You will get H3. How much is this? 3400, 3600. Okay. So here 50, So here you will get 3425 approximately, right? So this shape cheese, you will get H3. Okay, so from HS chart, H3 is how much? Kilojoule per kg. समजतंय का सगळ्याला प्रमाणात जाते आदित्य समजलं नाही समजलं तर नाही उगाच समजलं नाही समजलं तरी समजतंय असं समजतंय का लास्ट टाइम समजतंय का समोर येणार पहिली गोष्ट दिसतंय का दिसतंय ना समोर ओके now how to calculate H4 tell me how to calculate H4 isotropic process from that vertical line till it touches saturated vapor line. Okay, from this line, draw the vertical downward line till it touches saturated vapor line. This is your point 3. This is point 4. Right? From here, draw the projection. How much is this? 26, 28 is here. 26, 27, 28. How much it will be? 2750. 27 approximately. Yeah. I 10 points here and there. 3000 च्या व्हॅल्यू मध्ये 5000 पॉइंट इकडे तिकडे काय पडेल ओके सो how much value I will get 2750 so I will get 2750 so from HS star H4 is how much 2750 kilojoule per kg isentropic process. Isentropic process and saturated vapor line. Right? Okay. Then next at point 5 at point 5 pressure is how much? Pressure we need to calculate. Okay, at point okay here this intermediate pressure we need to calculate. Now how to calculate this intermediate pressure? We have located this point 4 on HS diagram, right? So go to HS diagram. Go to HS diagram. I have located point 4. Check this pressure line. How much is this pressure line? 5 bar. So intermediate pressure is how much? 5 bar. Okay. So from HS diagram, we will get the intermediate pressure. So intermediate pressure is how much? 5 bar. From HS diagram, right? Pressure is 5 bar. Temperature is how much? 400 degrees centigrade, right? So check the value of H5. Check the value of H5. This is 4. This is 5 bar pressure line. Temperature is how much? 400 degrees centigrade. check this 400 degree centigrade line. You can check this 400 degree centigrade line. You can check this 400 degree centigrade line. This 400 degree centigrade line. And this 5 bar pressure line. Where it intersects there. What is this point? Point number 5. Project this horizontally here. How much is this? 3200, 3300, 3275. 3275 or 3280. समजते नहीं? समजते फर्स्ट बेंच दोघींना समजतं? नेक्स्ट प्रॉब्लेम तुम्हाला सॉल्व करायचा सिमिलर. ओके. So how much is the H5? किती आलं H5 आपलं? 3280 kilojoule per kg. Right? Then H6 कसा काढायचा H6? How to calculate H6? प्रश्न विचारलेला चालतात ना तुम्हाला? काय अडचण नाही? मला विचारला तसं सांगा मला. हा H6 कसा काढणार? कसा काढणार H6? Yes, काय करावं लागेल? 5 to 6 is what? Center of process is vertical straight line. So first from 5 I will draw the vertical down line. कुठपर्यंत काढायची? Saturated vapor line इथपर्यंत. So that point is your point number 6. And from here we have to project the horizontal. Here. किती येणार ते? 2625, 2620, right? So S6 is how much? S6 is how much? Kilojoule per kg. या व्हॅल्यू तुमचा थोडेफार मागे पुढे होऊ शकतात, जास्त नाही, 10-20 पॉइंट. ठीक आहे. Up to here. Now what we need to calculate? We know pump work, right? Pump work is how much? 6.98 kilojoule per kg. Okay. So first thermal efficiency. How to calculate thermal efficiency? Thermal efficiency काय? Output of input. Output is what? Turbine work minus pump work. Pump work we have to minus. तुम्ही सेकंड इयरला सॉल्व केले ना बॉयलरचे प्रॉब्लेम. Turbine work minus pump work heat supplied. Right? So here turbine work is what? First turbine. पहिल्या टर्बाइन मधलं वर्क कोणतं? H3 minus H4. First turbine H3 minus H4. Second turbine plus. Second turbine plus. दोन्ही टर्बाइनचं वर्क ऍड करायचं. पंप वर्क मायनस सेकंड टर्बाइन वर्क H5 minus pump work minus pump work. Okay. Minus minus pump work divided by heat supplied. Heat supplied. Heat supplied साठी फॉर्म्युला कोणता? हीट सप्लाय साठी फॉर्म्युला हीट सप्लाय कुठून कुठं होते 2 पासून 3 पर्यंत. सो हीट सप्लाय फॉर्म्युला H3 minus H2. H3 minus H2. Okay. So thermal efficiency is H3 is how much? H3 3425 minus H4 2750 plus H5 3280 S6 2620 minus pump work 6.98 divided by heat supplied H3 minus H2 H3 3425 minus H2 258.43. From this thermal efficiency, how much is the thermal efficiency? Multiply by 100. So you will get in percentage. Multiply by 100, you will get in percentage. What's the time from the calculator? 7.5. What is the thermal efficiency? Ten point. Let's check it. 41. 41 point. 30-40 के आसपास आना चाहिए. 36 और 3.6. 41.93. 41.93. Please check. Percentage. Right. Now next, what is the next thing that you need to calculate? Working megawatt. Right. Now you already know turbine work here. This is the turbine work H3 minus H4 plus H5 minus H6. Tell me this turbine work. Turbine work. How much? H3 minus H4 plus H5 minus H6. Right? Now tell me how much is this work? Put all values and tell me the turbine work. Turbine work. One, 3, 3, 5. Unit is what? Unit is what? Unit का है kilojoule per kg. Enthalpy is unit is kilojoule per kg. Now what they have asked? Calculate the turbine work in megawatt. Right? So what they have given? mass flow rate of steam. How much is 10 kg per second? So multiply it with mass flow rate of steam. So turbine work in megawatt. 1335 multiplied by mass flow rate of steam, that is 1335 multiplied by 10. So please check the unit kilojoule per kg multiplied by kg per second. Kilojoule per second is kilowatt, right? So how much is this? 13350 kilowatt into megawatt divided by 1000. So divide by 1000. 13350 divided by 1000 megawatt. How much is this? 13.35 megawatt, right? So turbine work in megawatt. Got it? All of you, right?